Dear students, good morning. Let us see the Proell governor. Okay, this is the line diagram. Okay, okay. So this is the Proell governor arrangement, and this is the Porter governor. Okay, if you observe the both, okay, you observe the both are having the central weight. Okay, but here the balls are in downward direction. But here for the Proell governor, okay, the balls are attached to the upward extensions of the lower links. Okay. Here the Proel governor is similar to Porter governor, but the two balls are attached to the upward extensions of these lower links. Okay. See, coming to the working, whenever the engine speed is increases, okay, these balls are try to moving upwards. Okay, that means this radius of rotation. Okay, the balls are moving away from the axis. Okay, see, this is the normal position. Coming to here, suppose if the engine speed is increases, okay, here the balls will moving upwards. Then here the sleeve is moving upward. This is connected to the lever. Okay, throttle valve. Then the fuel supply will be stopped. Like that, the engine speed will be balanced. Similarly, for lower speed, vice versa. That means for lower speeds, the balls comes down and again this throttle valve will open and the fuel will again supply. This is the working. Next, let us see the derivation. That is, derive the expression for height of the Proel governor. This is very, very important, commonly asked in recent exams. Okay, let us see. So this is the line diagram as it said. These are the balls. B and C are the balls. Okay. Here the Proel governor has the balls fixed at B and C. To the extension links DF, DF and EG. These two are the extension links. Okay. And here FP and GQ are the arms pivoted points P and Q respectively. Okay. So from this line diagram, okay, we have to draw this figure to solve the derivation. Okay, let us consider one half of this portion. One half of this portion. So from this arrangement, you can see from the figure. So this is the half of the portion. Okay, the same is taken here with little modification. Okay. See the center axis. Sorry. This is the axis. The same is taken here. This is the central axis. Okay, and from that axis we are having P and D points. P and D points. Okay, P and D points. The axis we are having P and D points. Here, the P and D are making some angles. Okay, one is alpha. This is the alpha, and similarly, this is the beta. Okay, this is the ball having the centrifugal force Fc, and the ball having weight W. The weight is, and then here the sleeve having weight actually W, but here we have taken half of the portion, so W by 2. So here follow the instantaneous center method, that is the I. Okay, here we are extending that line up to I point from P to I through point F. Next, here also from D to I, from D to I. So here the both angles here and here alpha both are same. Similarly, here beta and here beta both are same. So we are taken like that, solving the derivation. Okay, let's come to that figure. So from this figure, let's take the movements about I. Take movements about here. See, FC into BM, BM into FC. You take movements about I. So this is in anti-clockwise direction. You can see this is in seen like this, anti-clockwise direction. Okay, and then W into IM. See, W into, okay, these are in clockwise. This one, and also W by 2 into ID. W by 2 into ID. These two are in clockwise direction. Okay, these two are, see, W by 2 into ID. Two are in here, W by 2 and small w. With respect to I, it is in the clockwise direction, but where FC is in anti-clockwise direction. So your movements, okay, so clockwise movements is equal to anti-clockwise movements. So you have to take like, so see FC into PM and W into IM. This distance, perpendicular distance. Similarly, W by T into this ID. Okay. So as you know, W equal to mg and W by 2 is W capital W is equal to capital M into G. Okay. Now, again, Fc is equal to mg into, let us take that Bm into this side. Then Im by Bm plus mg by 2 into, where ID is the here. Im plus D by Bm value. Okay. Let us multiply and dividing this equation by Fm to get the required equation. From this, see, let us take out Bm outside. Bm outside. That is here. Bm. And we are multiplying with Fm. You have to divide here again. Then the equation remains same. So from this, already this is at outside. This is multiplied. Then mg into Im by Fm. Okay, the Fm should multiply all the, so it should divide all the individual terms. So already Bm at outside and Fm is divided. And mg by 2, again Im by Fm plus md by Fm. Already Bm is at outside. Okay, now see mg. Here from this equation, let's see, this is alpha. You can write tan alpha is equal to opposite side by adjacent side. Sorry, opposite side by hypotenuse. That is Im by Fm. Opposite by adjacent side. Formula is opposite by Im by adjacent side Fm. This is not sin theta. This is tan alpha. So that's by opposite Im by Fm value plus mg by 2. See this one. Again, here also tan alpha. So coming to this one, see tan beta opposite by means md by Fm value adjacent. As you know, here you have to take out tan alpha outside, then Fm by Bm into tan alpha into mg by 2, 1 plus tan alpha by tan alpha. You can write this equation like this. So suppose if you cross verify here, you will get tan alpha plus tan beta by tan alpha. Here tan alpha get cancelled. Then you will get again tan alpha plus tan beta. Okay, that's why we are writing like this. Next, I am taking the same equation, the last equation, Fm by Bm into tan alpha, and this term that is taken here. This is the FC equation. Okay. I am taking the same equation from that equation. Okay, see, before that, as you know, F is equal to mr omega square, that is centrifugal force. And from this figure, see, this is the alpha, and this is the height, this is the height, this is the height. This is the radius of rotation from the axis to the center of the walls, and this is the h height from this point to this point, height of the governor. Okay, so from that you can write this is the alpha, tan alpha equal to opposite r by adjacent h, and we have a term q is equal to the ratio of tan beta by tan alpha. Let us substitute all these terms in this equation. Okay, so as you know, F is equal to mr omega square. F is equal to mr omega square. Fm by Bm. Tan alpha is equal to r by h and mg by 2 and 1 plus tan alpha plus tan beta. Substitute the q value. Okay, here you have to find out the n square value. So keep omega square here. Okay, here r and here r both get cancelled, and here m is here multiplying, but this side will be divided. Then Fm by Bm, and the remaining here is take out the g value outside and h also. Then we have m plus by 2 plus 1 by q. This m will divided here. Okay, So in this equation, we have a formula omega angular velocity 2 pi and 60. Let us substitute in this equation based on scale. We know G value 9.81 meter per second scale. After substitution, we will get the 895 by H. Term is remains same or terms the same. Only base of omega square. Okay, 2 pi into 60 whole square. Okay, and this is G value. Then finally we'll get 895 by H. This is the n square is equal to Fm by Pm. That is the speed. But in the exam, they ask find out the height of the governor in meters. Okay. So in this, Q is equal to 1, and when alpha is equal to beta, this equation will be modified as C n square Fm by Vm and M plus capital M. Here 1 plus Q, where Q, if you substitute Q as 1, 1 plus 1, 2, 2 and 2 get cancelled. Divided by M and 890 by H. This is for Proell governor. Okay. So from this governor, okay, you can find out the H value, where H is the height of the governor in meters. So then H will be Fm by Bm into M plus capital M by M and 895 by N square. That is the H value. That is the height of the governor. Very, very important derivation. It is commonly asked. Here, compared to this equation, while solving the problems, okay, you have to neglect the obliquity. That means you have to take alpha equal to beta. You have to neglect obliquity of arms. That means you have to consider alpha is equal to beta. They didn't mention, you have to take directly alpha is equal to beta, then you get this equation. This is for Proell governor. Okay. Compared to the port governor, see, almost same. This is for port governor. This is the Proell governor. The only term is Fm by Pm. Okay, where Fm is the C here. This is the F, and this is the F, this is the Fm point. And where Pm is the C from B to Pm. This is only the extra adding to the water governor formula. Remember easily. Okay. And also the balls arrangement is here upward. There is a downward. Direction. So this is downward direction. Here the balls are in upward direction. This is the Proell governor. Okay. So in the rear completed the working of the Proell governor and derivation. That is the height of the Proell governor. Okay. Thank you. In the next class, we will see the